from B to C are 1 functions, then G circle F from A to C is also 1 function. Here F from A to B, F from A to B is 1 function. 1 function means what? According to definition, for all x1 comma x2 that belongs to capital A domain. Capital A means it's a domain, and let or f of x1, they are taking like that, f of x1 equal to f of x2. That implies x1 is equal to x2. x1 is equal to x2. Remember, we are just, it is what? Only x1, only x2. It is what? f of x1, f of x2. Means, what is the difference between this step and this step? There is no f. Means, bluntly, we are striking like that. Remember, for 1 function. Means, f of x1 equals to f of x2. That implies we are deleting, erasing f. Just we are writing only x1 is equal to x2, just like that. Remember this procedure. Remember this notation. Okay. Here G circle f from A to C, we have to show that 1 function. That's why in its domain capital A, let, this is the proof. This is the proof. Let x1, just like that, x1 comma x2 belongs to domain capital A. This is domain of G circle F. Domain of G circle F. Okay. Next, assume like that. G circle F of x1 is equal to G circle F of x2, just like that. Okay. Next, so that implies G circle means only one bracket, maintaining the bracket, that's all. That is equal to G of f of x2, f of x2. So that implies what I said here, just erasing the letter F, just like that. Understand? Right. So it is f of x1 is equal to f of x2. Since G from B to C is 1 function. 1 function. Next, that implies it is x1 is equal to x2. Since f from A to B is 1 function, therefore for all x1 comma x2 that is belongs to capital A and G circle f of x1 is equal to G circle f of x2, that implies x1 is equal to x2. Therefore G circle f A to C is 1 function. It is very simple theorem for board syllabus. Okay, this theorem is over. Next, important note. What is that? Converse means what? G circle F from means G circle F. G circle F is if G circle F is 1 function, then F must be 1, but G may not be one function. One function means converse is not true. So I will explain this statement through the example. This is the important theorem, and this note and with example is also important for public examination. Here capital A, capital B, capital C, A, B, C. So A to B, F, it is defined. G, B to C defined. Here A, B. Take 1, 2, 3. XY. 1, 2, 3, XY. A is mapped with 1. B is mapped with 3. Therefore, here clearly F from A to B is one function, because different elements are mapped with different elements of B. Okay, F is 1, 1. Next, 1 is mapped with X, 3 is mapped with Y. Here G from B to C is not 1 function. Of course, it is not a function. Not only 1 function. It is not a function. That's just I wrote not 1 function, because we are talking about whether G is 1 function or not 1 function. Okay. Next, what about G circle F? G circle F. G circle F A to C means A is G circle here. G circle F A to C means A, G circle F of B. So G circle F of A is what? G of F of A, that is equal to G of F of A. F of A equal to 1. Already I said the meanings. Next, what is G of 1? G of 1 is X, that is equal to X. Next, it is G of F of B, that is equal to G of F of B. F of B is 3. Next, what is G of 3? G of 3 is Y, that is equal to Y. So therefore A, B, different elements, X, Y, different elements. Different elements are mapped with different elements. Therefore clearly G circle F from A to C is 1 function. So therefore G circle F A to C is 1 function. F is 1 function, but G is not 1 function. 1 minute. Another example. Second example for the same statement. So this is capital A, this is capital B, this is capital C. So F, Z, A, B, 1, 2, 3, X, Y. A is mapped with 1, B is mapped with 3. Therefore F is 1, 1. F is 1, 1. Next, 1 is mapped with X, 2 is mapped with X, 3 is mapped with Y. Here G means different elements are mapped with only 1 element. Therefore G is not 1 function. Next, clearly G circle F A to C is 1 function. Function. So therefore, by through these two examples, G must be one function. F must be one function. F must be one function for G circle F A to C one function. But G may or may not be one function. Means for example, another capital A, capital B, capital C, this is F, this is G, okay, A, B, 1, 2, X, Y, A to 1, 1 to X, B to 2, 2 to Y. So F is a one function. Okay, here G is also one function because different elements are mapped with different elements. Next, G circle F is also one function. So ultimately, for G circle F one function, F must be one function. G may or may not be one function. So for this statement, I have given 3 examples. This is the important. If F from A to B and G from B to C are onto functions, then we have to show that G circle F from A to C is also onto function. So once again, I recall the definition of onto function. For example, F from A to B is an onto function. Then what is the definition? This is capital B, this is capital A. One image is appearing in codomain. This is codomain. Or image set. This is image set. It will be pre-image set. One image, one object or one element is here. Definitely its pre-image will be here. At least one pre-image will be here. Then only it is onto function. Otherwise it is not an onto function. So mathematically we should write as for all B belongs to capital B, one image is there, then definitely there exists at least, means at least, it is to be understood, there exists small a belongs to capital A, so that actually it is f of A equal to B. F of A is equal to B. This is the definition. Similarly, G, for example, capital B, this is capital C, B to C, G function. Onto function. G from B to C is onto function. Let small c, for example C, one image is here. Definitely it's related pre-image, at least one pre-image will be here. It is called onto function. Mathematically, for all C belongs to capital C. Capital C means codomain. We are discussing the codomain first. Codomain, there exists, suppose B. B belongs to capital B, so that G of B equal to C. G of B equal to C. This is the definition of onto function related to F and G. Okay. Now, we have to show that here already given F from A to B and G from B to C are onto functions. Here, this is capital A, this is capital B, capital C, A to B F, B to C, Z. Here, we are assuming or we are let some Z in C. Let C belongs to, let the element is Z. Z that is belongs to codomain of Z. Codomain of Z. This is codomain. Codomain of Z. Codomain of G means image set. Image set. Okay. Okay. G actually, G is onto function. It is given. Definitely for all Z belongs to capital C, there exists one pre-image, say Y pre-image that is belongs to capital B, so that G of Y equal to Z. G of Y equal to Z because G is onto function. It is already given. It is given. If we are assuming one element in capital C, definitely for this image, at least one pre-image will be in capital B, so that Z of Y equal to Z. I wrote the definition, that's all. Okay. So, for all Z belongs to capital C. Okay. Next. And F is also onto function. What he said? F is onto function. F is onto function. Forget it. One element is here. So therefore, for all Y belongs to capital B means it is the image. There exists at least one pre-image in capital A, so that f of x equal to y. So that f of x equal to y. Since f is onto function, just I wrote G is onto function definition, F is onto function definition. First step, our assumption Z belongs to capital C. By taking one element here, by assuming one element, one image in capital C, from backside, from in this reverse direction, I used simultaneously or gradually the onto function definitions. Understand? Okay. So, for all Z belongs to capital C, so that implies here apply G of on both sides. Okay. So that implies of means circle is equal to G of Y, but G of Y equal to Z. This is Z. Therefore, for all Z belongs to codomain capital C, there exists X belongs to capital A, so that G circle f of x equal to Z. What does it mean according to onto function definition? G circle f from A to C is onto function. So therefore, if f and G, so that the codomain of f is equal to domain of G are onto functions, then G circle f from A to C is also onto function. Okay, next you come here. Here, note, most important note. Note, for G circle F onto is onto G must be onto, but F may not be onto. It is the important point. Means its converse is not true. Just like that. Okay. Here I will explain through one example. This is capital A, capital B, capital C. A, B, 1, 2, 3, say XY. F, A to B, A1, B2. Next, 1x, 1 is mapped with X, 2, Y, 3 is mapped with Y. Listen, here F, listen, F from A to B. For F, B is the codomain. In codomain, for the element 3, there is no pre-image. For this 3, there is no pre-image. Therefore, F from A to B is not onto function. Next, G. Next, B to C. G. G from B to C. X. We are verifying onto function, not one function. C. Codomain. It is codomain of Z. I am asking one question. X is the image of which element? At least one pre-image is there for X. Yes, is there. Next, second element. Y. It is imager. This Y, the element will possess at least one pre-image in capital B. Yes, at least one. Okay. It has two pre-images in capital B. Thus, is onto function. Next, now G circle F from A to C. X, it is the image of 1. 1 is the image of A. Therefore, it is the image, its pre-image small a in capital A. Similarly, Y, it is the image. Y is the image of 3. 3 is Y is the image of 3. Okay. For this 3, there is no pre-image. Y is the image of 2. 2 is the image of B. Understand? Therefore, is onto function. Once again, here X image of 1. 1 is image of A. So therefore, X image A, its pre-image. Y image 2, its pre-image B. Therefore, clearly it is onto. So therefore, for G circle F is onto function, G must be onto. If G is not onto, we cannot write like that. Therefore, F may or may not be onto, but G must be onto. Then only G circle F from A to C is onto. Hence the theorem. This theorem with proof, with example, this statement is very, very important for board level examination. Small and important definition. Already I said, if F is one function and onto function, then f is called bijective function. Bijective, f is called bijective function. Actually, here we are defining inverse of the given function f. Now we are going to define the definition of inverse of f. Actually, if f is a bijective function, then only f inverse or inverse of f is exist. Otherwise, it is not exist. So therefore, before finding the inverse of f, we have to examine first whether it is a bijective function or not. Bijective means one function and onto function. So therefore, if f is a bijective function, then only f inverse exists. Otherwise, it is not exist. Okay. Next, inverse of f. This definition. Let f from capital X to capital Y and g from capital Y to capital X be two given functions, so that f circle g is equal to I y and g circle f is equal to I x. Means what? The complete meaning is f of f circle g of g means what? This one g, its domain is y, so small y, that is equal to capital I of y, whereas y belongs to capital Y. Its complete meaning g circle f of, so last letter f means domain is x, so it is small x, that is equal to capital I of x, whereas x belongs to capital X. So therefore, if these two conditions are satisfied in this case, then G is called inverse of f. It is denoted by f inverse, that is equal to G. This is the definition. So therefore, let f from capital X to capital Y and g from capital Y to capital X be the two given functions, so that f circle g equal to Iy means identity function. Iy means complete meaning I wrote here. G of f circle g of y equal to Iy and g circle f equal to Ix, that is g circle f of x equal to Ix. Then f inverse is equal to G. G is called the inverse of f. This is the small definition. Another definition is there. So in other words, we can define like that. Number one, let f from capital X to capital Y and g from y to z be given functions, or be two functions, so that f circle g equal to y, last letter g, so its domain is y, so it is y means Iy, and g circle f equal to last letter f means f function, its domain is x, Ix, then f inverse is equal to G. G is called f inverse. This is the second definition. Almost all in the problems we are using this second definition. So both are definition for the inverse of the given function f. So therefore f inverse equal to g, and here f comma g are said to be invertible functions, invertible functions, right? Come here, what is f circle, f inverse? Here f inverse, actually f is what in this definition? F x to y, it is f. Next, what is g? Means y to capital X is g. So already I said about composition of f comma g. So this is x to x, g to f. So therefore g circle f is x to x, x to x. It is called identity function. So simply it is denoted by g circle f is equal to I capital X or capital I of x. We can represent like that. Okay. Next, f from x to y. Then f inverse defined as y to x. Means what? Its domain becomes the codomain of f inverse, and its codomain becomes domain of f inverse. You observe this. Okay. So capital X to capital Y, Y to capital X, X to Y is f function, Y to X is f inverse. According to this order, so X to X, f inverse circle. So f inverse circle f is capital X to capital X. So simply f inverse circle f equal to I x or capital I of x. So therefore we can write it as f inverse circle f equal to simply Ix. You will have to make a note, f inverse. Similarly f inverse we are finding f circle f inverse. So here f inverse is what? F inverse y to x, y to x. Next x to y, y to x is f inverse. X to y is what? F. So y to y in this direction, cyclic direction. So f circle f is y to y. That is f circle f inverse. F circle f inverse is equal to or is equal to capital I y. You can ask me, sir, what is the need of writing I? Actually, I stands for the identity function. Means what? Y is one side. Y is one side means this is capital Y. This is also capital Y. Means it is 1, 2, 3. It is also 1, 2, 3. What does it mean? What does y to y means? 1 to 1, 2 to 2, 3 to 3. So 1, this element is mapped with itself. 2 mapped with itself. 3 is mapped with itself. Just like that. Understand? So that's why we wrote IY. So these are the complete meanings and simple notations. So we have to remember, especially for the problems, this definition. And f inverse circle f is Ix, and f circle f inverse is Iy. We have to make these three notes. Once again, it is better to write here f inverse circle f equal to I capital X, and f circle f inverse is equal to I capital Y. This is the procedure. This is the synopsis about the bijective functions or inverse functions, and at the same time invertible functions are, it is called as bi-uniform functions or non-similar functions or bijective functions or invertible functions. We can say like that with different names. Remember.